Hello viewers, tutorial 9 question 6. Differentiate sec squared of x and tan squared of x. What do you notice? So we'll start by differentiating sec squared of x. So let's say y is sec squared of x, which is another way of saying sec x, whole thing squared. So we've got the secant function inside the squaring function. So we can say that z is the secant function, z is sec of x, and we can say that that makes y equals z squared. Okay, so we need to differentiate both of those. We're differentiating by the chain rule. We have function inside a function. So dz by dx is secant differentiates to secant times tan, and if we differentiate y squared, we get z squared, we get dy by dz is 2z. Okay, so that tells us that dy by dx equals, we want to find dy by dz times dz by dx, which is going to be dy by dz is 2z multiplied by secant of x times tan of x, and what was z? Z was the secant function, so we've got 2 times sec x times sec x, so we've got 2 times sec squared of x times tan of x. Okay, so that's the first of the two functions differentiated. Now we need to differentiate tan squared. So our approach is going to be the same. So we'll say y is tan squared of x, which is, as before, tan of x squared. So z steps are going to be the same, except now z is going to be tan of x, and still we're going to have y equals z squared, because both functions have whatever's inside the bracket squared, so they will both be z squared. Okay, so dz by dx equals sec squared of x, and we also have dy by dz equals 2 times z. So we've got dy by dx is dy by dz times dz by dx, which is going to be dy by dz is 2 times z times dz by dx is sec squared of x, which is going to be 2 times z is tan of x times sec squared of x. So we get actually the same function as what we got when we differentiated sec squared, because they might look slightly different, but that's only in an order of multiplication, so they are really exactly the same thing. Sec squared and tan squared have the same derivative. Okay, thanks for watching. Over and out.